Hello class, and welcome to section 9.2, which is about solving quadratic equations by factoring. By the end of today's lesson, you will be able to use factoring to help you find the solution to quadratic equations. The first thing I want to go over is just a quick piece of vocab. It's called the zero product property. That means for any real number a and b, if a times b equals 0, then either a is 0 or b is 0. So basically what this is saying is if you're multiplying two numbers, either the first one has to be 0 in order for it to equal 0, or the second number has to be 0 in order for it to equal 0. So it's basically saying multiplying by 0 gets you an answer of 0. Now, using this, the factoring part is going to help us find the solution. So if I have x minus 9 and 5x plus 2 equals 0, this has already been factored for us. So what we can do then is use this zero product property rule and say that either x minus 9 has to equal 0 or 5x plus 2 has to equal 0. So in order for the final answer to be 0, one of the two pieces needing to be multiplied has to equal 0. So then you can go through and solve both equations. The first one, you would simply add 9 and get an answer of x is equal to 9. And the second one, you would subtract 2, giving you 5x equals negative 2. And then you would divide both sides by 5, giving you a final answer of x is equal to negative 2/5. We're going to want to make sure that we keep those answers as fractions and not as decimals. So basically what this says is if I plug in 9, 9 minus 9 is 0, 9 times 5 is 45 plus 2 is 47, 0 times 47 is 0. On the other hand, if I plug in negative 2/5, negative 2/5 minus 9 is negative 9 and 2/5, and if I plug into negative 2/5 here, 5 times negative 2/5 is negative 2 plus 2 is 0. So negative 9 and 2/5 times 0 equals 0. So both of these answers are our solutions to this problem because that's what makes the factors turn into 0. Go ahead and solve this one on your own. You end up with an answer of 5/3 and negative 2. When you are solving by factoring, the biggest thing is that it has to be set equal to 0. So in order to be able to apply that zero product property rule, the answer has to be 0. So the first thing I'm going to do with this problem is add 20 to both sides, so that cancels out and we can get our answer equal to 0. Then our equation becomes x squared plus 9x plus 20 equals 0. This puts us back into our chapter 8 learning where we had to factor. So we need to find the things that multiply to 20 that add up to 9. So our options are 1 and 20, 2 and 10, and 4 and 5. 4 and 5 can be used to get us to 9. So I'm going to say x plus 4 times x plus 5. If you want to double check your work, you can really quick go x times x is x squared, x times 5 is 5x, 4 times x is 4x, 5x and 4x give you the 9x, and then 4 times 5 is 20. So now that's equal to 0. Then using our zero product rule, we can say x plus 4 is equal to 0, and x plus 5 is equal to 0. Then you're going to go ahead and solve both of those. The first one by subtracting 4, giving you that x is equal to negative 4. And the second one by subtracting 5, giving you that x is equal to negative 5. Now, when you want to check your work, you can plug these answers back in. So if I do negative 4 squared, I get positive 16 plus 9 times negative 4, which is negative 36. 16 plus negative 36 is negative 20. If I plug negative 5 back in, negative 5 squared is 25, plus 9 times negative 5 is negative 25, or excuse me, negative 45. 25 plus negative 45 is again negative 20. So our two solutions to this problem are x is equal to negative 4 and x is equal to negative 5. Go ahead and try this one on your own. So split it up. Your factors are positive 4 and negative 16 for this one, giving you final answers of negative 4 and positive 16. Sometimes we're going to have to use that box method while factoring. That's what happens when you have a number in the front. First thing you check is, can you reduce? 12, 13, and 3 can't be divided by the same number, so we cannot reduce. Then you would go ahead and do 12 times 3, which is going to give you 36. So you're finding the factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The factors that can get me to 13 in the middle are going to be 4 and 9. So you're going to go ahead and set up that box, remembering that in the top left corner, so in that first space, you're going to put the front value. So in this case, your front value is 12x squared. In these diagonal two boxes, you're going to split 13x up. I'm going to put 4x here and 9x over here. And then you have your back factor in that remaining box. Now you look at those first two in the left column and you say, okay, 12 and 4, those can both be divided by 4. If you have x squared and x, you can pull out one of the x's. Now we need our other factors. To get from 4 to 12, you need 3. To get from x to x squared, you need x. Then on the bottom, to get from 4 to 4, you need 1. To get from x to x, you need nothing. Then go in the other direction. To get from 3 to 9, you need 3. X to x is nothing. To get from 1 to 3, it's 3, so that checks out, giving us factors of 3x plus 1 from that left side of our box and 4x plus 3 from the top of our box. And then that's going to equal 0. So now we're going to set each of those factors equal to 0. So I've got 3x plus 1 equals 0, and 4x plus 3 is equal to 0. Then we need to solve, and in order to do that, I'm going to subtract 1 from the first equation, giving me 3x is equal to negative 1. And then to finish, I'm going to go ahead and divide by 3 on both sides, giving me an answer of x is equal to negative 1/3 for our first solution. And then on the other side, I'm going to subtract 3, and that's going to give me 4x equals negative 3. Dividing by 4 on both sides gives me x is equal to negative 3/4. So again, if you're getting fractions, make sure you are leaving them as simplified reduced fractions. Go ahead and try this one on your own. Make sure to set it equal to 0 first and then use the box method. So subtracting 2 to get it set equal to 0, multiplying 2 and 7 to get 14. Your factors are going to be 1 and negative 14. Plug those in, factor it out. You end up with an answer of 2 and negative 1/7. Last thing we're going to do is go through a word problem. So a picture inside of a frame has an area of 375 inches squared. If the width of the frame is x centimeters all the way around, find the value of x. So what we need to do here is set up our equation. We're looking at area of a rectangle, so that means we need base times height. So the area they give us is just for the inside picture. So we need to figure out how tall this height is. they tell us the whole frame is 30. So I've got 30, but then I have to take away the top x and the bottom x. So I'm going to take away twice times that width. That's how far it is up and down. Looking across, the whole way across is 20, but I'm going to have to, once again, take off twice times that width, and that area is going to equal 375. So in this case, we're taking it away. In some cases, you're going to be adding on that x. So if they give us the area of the whole piece, we would be adding on the x's instead of taking them away. So you have to read the problem carefully to decide whether you're adding or subtracting those x's. Then you're going to have to go ahead and do what we did in Chapter 7, which is use FOIL to solve. So we've got 30 times 20, which is going to give me 600. Then we've got 30 times negative 2x, which is negative 60x. Then we've got negative 2x times 20, which is negative 40x. And then we've got negative 2x times negative 2x, which is going to give me positive 4x squared equals 375. Now, this looks a little backwards compared to what we usually have because usually the x squared is in front. So while I'm combining terms, I'm also going to rearrange. So I'm going to put this 4x squared in the front. It's positive. And then I've got negative 60x and negative 40x, which gives me negative 100x. And then I've got a positive 600, and that still equals 375. So all I did was combine my like terms and rearrange it so that the 4x squared was in front. Now I need to get my problem set equal to 0. So I have to get rid of that 375. So I'm going to subtract that from both sides of the equation. And when I do that, that's going to give me 4x squared minus 100x plus 225 equals 0. Now at this point, you would want to check if you can reduce. Unfortunately for us in this example, 4, 100, and 225 cannot be reduced. But again, you want to make sure that you check for reducing. Then we would do 4 times 225, which is going to give us 900. So I need my factors. I'm going to start at 1 and 900, 2 and 450, 3 and 300, 4 and 225, 5 and 180, 6 and 150, 9 and 100, and then we get to 10 and 90. You could keep going, but 10 and 90 is what is going to give us our factors to get to 100. So I'm going to go ahead and set up my box now because I have a number in front of x squared. So we have to set up the box. So that first term goes in front. That gives us 4x squared in front. And then to use 190 to get to negative 100, I'm going to plug in negative 10x and negative 90x. And then we've got our 225 in that last box. Looking at the first factors, 4 and 10 can both be divided by 2. And then x squared and x, we can pull out an x. To get from 2 to 4, I need 2. To get from x to x squared, I need x. To get from 2 to negative 10, I need 5 with no x's. To get from 2 to negative 90, I'm going to get negative 45. And then double check negative 5 times negative 45 is indeed positive 225. So that means my equation right now says 2x minus 5 times 2x minus 45 is equal to 0. Now I'm going to have to go through and solve those pieces. So 2x minus 5 equals 0, and 2x minus 45 equals 0. When I solve the first one, I'm going to start by adding 5 to both sides. And that's going to give me 2x is equal to 5 dividing by 2. That's going to give me x is equal to 5 halves. Over on the other one, I'm going to add 45, and that's going to give me 2x equals 45. Dividing by 2 gives me x equals 45 over 2. Now, because it's a word problem and it's asking for us to solve for the value of x, you can go ahead on these ones and simplify these fractions. So this first one is going to give you 2.5, and our second one, when I do 45 divided by 2, is going to give me 22.5. So now I need to decide which of these answers actually work. If I plug in 2.5 and find the width here, so 20 minus 2 times 2.5 is 20 minus 5, which gives you 15. If I plug in 20 minus 2 times 2.5, that's going to give me a negative answer, and we can't have a negative width. So this one does not end up working. It's a solution to this equation, so it's a solution to that original blue equation, but it doesn't make sense in the context of our problem. So our answer for the width of the frame is going to be 2.5 centimeters. So on these word problems, you have to go through and figure out which of your answers actually makes logical sense within the context of the problem. So for this last one, a museum has an outer steel wall with a width of x feet. The area of the ceiling, which includes the outer steel wall, is 1,664 feet squared. What is the width of the outer steel wall? So you need to set up an equation, factor it out using FOIL, go ahead, set it equal to 0, reduce it if you can, and then do your factoring, and finally figure out which answer makes logical sense. Go ahead and try it on your own. So we write our equation. This time we're adding on that outer edge, reduce it, subtract it over. You find your factors are 6 and 36. You don't need to use the box because it's just x squared in the front. When you solve, it doesn't make sense to have a negative amount of feet, so your final answer is 6 feet. If you have questions about this or anything else from the lesson, please let me know when you get to class.